Let's take a look at how to answer the practice questions on series and parallel circuits, and there is also some work on current and potential difference and resistance curves. Let's take a look at the first question. So the first thing I'm going to do when I'm looking at this question is try to unpack what I'm reading. So I can see straight away that I'm given some information. I've got a circuit diagram. I've got my clues here that it's in parallel, and let's look at the text. So figure 1 shows a circuit diagram containing two identical lamps. That's really key that they're identical. It tells me they've got the same properties in terms of resistance, and they're in a parallel circuit. The reading on the ammeter, which is telling me that's current, is 186 milliamps. Let's do that in green. 186 milliamps. So one thing I do know is that current is measured in amps, not milliamps. So I need to unpack this a little bit, and mil means 1,000. So that tells me if I want to convert milliamps to amps, I need to divide this by 1,000. So I've got 186 divided by 1,000. And I don't need a calculator for this. I just know that I need to move each digit 3 places to the right, which gives me the number 0.186 amps. So before I've tried to answer any questions, I've just quickly converted this into amps, something that's usable for the rest of the question. The question then asks me, which statement about the current through the lamps is true? Tick one box. So I need to tick one box. That's important, that one, because on some questions I've seen recently people answer it, they've been asked to tick 2 boxes, they've only ticked one. And so I've lost some really easy marks there. Well, I know that the current through the lamps is identical, so I'm looking for a number that's represented twice here. Let's take a look at the first option. The current through both P and Q is 0.93 amps. I've got current through both P and Q is 0.86 amps, and then current through both P and Q lamp is 0.93 amps. Sorry, this one was 0.093, and the current through both P and Q is 1.86. Well, the number that I've got to work with to start with is 0.186, which is this number here. Now, that's not necessarily going to say that that's the correct answer, because what I should remember about current is that as the electricity flows from the cell, goes into the ammeter and gives us this reading here, which we've just converted to this, 0.186. So I know that at this point I'm getting 0.186 amps, and I know that at this point I would get the same, 0.186 amps. However, as it's a parallel circuit, we should know that current separates and is shared equally between the two components before it comes back. So if we've got this number here, which is shared equally, shared between two, we are looking for, then let's find a space for it. We're looking for 0.186 divided by 2, because it's all of that current divided across the two bulbs, as we can see the direction that it travels, like so. So 0.186 divided by 2 equals 0.093. So this is the correct answer. So we've ruled out that one because we know that's not shared. We've ruled out that one because that's not being correctly converted. And we've ruled out this one because there isn't the correct number of decimal places in there. And this is the correct answer. So quite a lot of unpacking and learning in that question, but if we're able to remember the rules about current being shared in parallel, and if we just notice that this is milliamps and we just needed to convert it by moving it 3 decimal places to the right, we just needed to divide whatever that number was by 2. So we should be able to do that at speed during the exam. So the next question tells us that one lamp breaks and is not replaced. So that tells us that the circuit would be broken itself, and initially we had 0.168 amps of current going through both of them. They now both don't need that. So current is shared, and because of that, the one remaining bulb doesn't need 1.86. It still only needs its 0.093 amps, half of that. So all of the current doesn't go back to that one bulb. It just reduces to the amount that that one bulb needs, which will be the first one. So the current through lamp A is 0.093 amps. Question C, a circuit shows that, figures 2 shows a circuit that can be used to alter, so to change the brightness of the lamp. I'm going to make that green. Change the brightness of the lamp. It then says the resistance of the variable resistor, that's this thing here, is increased. So what effect will this have on the brightness of the lamp? So this is kind of a reasoning question, or like an AO2 question. It's asking me to think, if this changes, what's the likely result of that? And it's worth 2 marks, so I need to be putting in 2 well thought out points. So I know that the resistance of the variable resistor increases, so as, let me make that black, as resistance increases, well, I know then the current will, pause the tape, fill in the blanks. That's right, it will decrease. And it asked me what effect will it have on the brightness of the lamp, and I've got to be really specific about that. I can't put that the brightness will change. That's not enough. I've noticed in some questions people aren't being specific enough. They're saying things change, but we need to know how. It changes specifically if the current's reduced, then it will be dimmer. The lamp will become dimmer. So I'm specific about what change there is, with the bulb, and what it does to the current. So there's the 2 marks that I've got there. So current decreases, therefore the lamp becomes dimmer. Next question, when the potential difference, so that's the voltage, across the lamp is 3.3 volts, the current is 0.15 amps. Write down, command, the equation that links current, potential difference and resistance. Well, this is something I should be really smart at now. V equals IR. I should just be able to remember that. That's an example of a knowledge question. I should just know that. Even though it says this stuff here, it's just asking me to write that down, recall it, know it. So this, you need to be able to remember and recall as quickly as that. So for the next question, I do need this information, so I need to go back a step, and now it's saying use this, so calculate the resistance of the lamp. So this is the formula that links them all together, V equals IR. Turn that into my triangle by just putting the thing that the equals bit to the top. V equals IR. I need to find out now the resistance, so I cover that up and I'm left with V over I. So R equals V over I. So that means that R equals 3.3 volts. I don't always have to do that, putting the units there, but I do. So that's 3.3 volts divided by 0.15 amps. So R equals, well, just so I'm kind of estimating, getting the right kind of idea in my head, I know that when we divide by a number less than 1, it's going to make my number increase in size. So 3.3 divided by 0.15 equals 22 ohms. So the answer there is 22 ohms. So this working out, actually, I should have done all the way up here and make sure I put my answer where it asks me to do that. I'm just going to get rid of that a second and go here like that. So that's 22 ohms. Next question. Sketch a current potential difference graph for a filament lamp. Well, this is my IV characteristics graph that we studied in detail and we wrote a lab report on. So if I've got potential difference at the bottom, which is my independent variable, the thing that I'm going to change, and then I've got current at the top, which becomes on my y-axis, that's my x-axis, which becomes my dependent variable. So if I change the potential difference, the current does what? It depends on what I do. Sketch a current potential difference for a filament lamp. Well, I should know that a filament lamp works by increasing potential difference. The more energy those electrons have as they flow through the filament, the more collisions they have with atoms. Therefore, the more energy is released as heat. The bulb starts to get hotter. The more the electrons collide, the greater the resistance there is. So resistance increases. So as resistance increases, it then means that we start to get this plateau point here where current starts to slow down because resistance is increasing. It's making it harder for the electrons to travel through the filament. And then we get that curve and eventually that plateau. And it's at that point that heat energy heats the filament up so much that it starts to emit light, so it has heat and light energy. And it's really important here that I start from the origin there, because you might be asked questions where you're asked to interpret this kind of business as if it did that. Well, you just know that by doing that you're talking about negative current, negative potential difference. So basically, if you were to reverse the flow of electricity. So, question 2, the diagram shows the circuit used to obtain the data to get the plot for the filament bulb. So this is the circuit that was used to get the graph, the data to produce this graph here. This one here. Now it's simply asking, what is the component labelled J? So what is this called? That's an example of a knowledge question. It's an AO1 kind of question. You should just know it. Well, it's a rectangle, which tells me it's a resistor, and it's got a line through it, which tells me that it's a variable resistor. Resistor. I should have written that here. So next question asks us, tells us the resistance of the bulb increases, potential difference across it increases. Why? So why is there more resistance when the potential difference goes up? A couple of things you can write here. We could write, well, I know that, the temperature increases. We know that increasing temperature increases resistance. Or we could put, there are more collisions between electrons and atoms. So the electrons have basically got more energy, so they collide more with the atoms in the wire. As they collide more, they release more heat energy and the temperature increases, therefore resistance increases. And that all comes as a result of increasing potential difference. All right, and for the final question, it says the bulb is at full brightness. Use that green. The bulb is at full brightness when the potential difference across the bulb is 12 volts. So I've got 12 volts here. I'm just making notes of important information. 12 volts, and the current through the bulb, the current is 3 amps. So I've got potential difference of 12 volts and current of 3 amps. So it now asks me to calculate the power of the bulb when it is at full brightness and give the unit. So it's now asking for power. So I need another formula that I can use to calculate power. So this isn't the V equals IR or Q equals IT. This is another formula, and there are two formulas that we studied for calculating power. The first one was power, P equals V times I. And we had the formula triangle which looked like this, P, V, I. And then we had the other one, which looked like this, P equals current squared times the resistance. Now, out of those two equations that we've got there, pause the tape, look back at the question, number 2 here, and then try and figure out which is the correct formula that we're going to use based on the information we've been given. Or we can use the one that has this or this business. So we should see that what we need is the voltage and the current. We've got those things. They're the only bits of information we've got. So in this case, the formula we must use, the one we've got to remember, is P equals V times I. We're not given any information on resistance here, so we could rule this one out. So with that in mind then, we now know that P equals V times I. So power equals 12 volts times 3 amps. So therefore power equals 36. Now it says here power equals 36. I'm going to write it where it asks me to write it, but it also says give the unit. So this question is worth 3 marks. It's telling me to give the unit, so that's worth 1 mark. My working out is worth 1 mark, and my right answer is worth 1 mark. Power is joules per second, and it is watts, measured in watts. So what is a joule per second? So it's the amount of energy transferred every second. In the next question, it says, in this question you'll be assessed on using good English, organising information clearly and including specialist terms where appropriate. I'm not going to assess you on that. This is an example of an older question that was from previous specifications. The content's still relevant. You might be asked a similar thing in the new exam, but you won't be asked to do this. You won't be marked on using good English anymore. So you could potentially just write everything down in bullet points and get the marks as long as they're structured well, but still have specialist terms in there where they're needed. So the question says, the table gives data about 2 types of light bulb people use in their homes. One is a halogen bulb. That's like the filament bulb that we've been using, but even less efficient actually. And one is a light emitting diode. So this is an example of a question where I'm looking for people to be interpreting data, using the data that you've been given well to make informed decisions. Before we unpack the table a little bit, it asks us, it tells us both bulbs produce the same amount of light. So they're just as bright as each other. So based on the fact that they're equally bright, they light your room up as well as one another. Evaluate, so think about the pros and cons and then make a decision about which is best in terms of cost, how much they cost, how efficient they are. Evaluate the use of the 2 bulbs. To gain full marks, you must compare both types of bulb and conclude which is the best. So it's asking you to think of the positives. It's asking you to think of some positives and some negatives, so good things and bad things about the bulbs, but then decide on which you think is best. So in the interest of time, I'm just going to whiz through some of the points that you have. So relating to cost, we could have the following points: that halogen are cheaper to buy, much cheaper to buy. Cheaper to buy, not necessarily to run. You might say that you could get 6 halogens for the price of 1 LED. You could say that LEDs last much longer, so maybe are more cost effective in the long run because they last a lot longer. You could say that you'd need to buy up to 18 halogen to last that amount of time, because that divided by that equals 18. So you need to buy 18 halogen bulbs in the lifetime of just 1 LED. 18 halogens costs £35. You might say that £35.10. You might also say that it just costs more to run halogen. So bear in mind this is worth 6 marks. We've already got 1, 2, 3, 4, 5, 6 marks there. So halogen is just much less energy efficient, so they cost more to run. And in terms of energy efficiency, there's another kind of set of answers we could use. Efficiency, my handwriting's terrible. Energy efficiency, we could say that LEDs, and this is based on things we know, work with smaller current. They work with, they use less energy, so your bills will be cheaper. They are more efficient. It could be more specific than that and say they're 22% more efficient. They produce less heat, therefore less waste energy. And they require much smaller energy input. Okay, that's it for the first set of questions. The next set of questions will come in a separate video because these videos are getting quite long and they do take a long time to upload when they're large files. So I hope this one helps. Mark your work against the questions here. See if you can pick up any misconceptions, see anything you did wrong, and try and correct that in your work. Keep your eyes peeled for the next video. I don't get confused.